Integral comparison property number 1. If f of x is bigger than or equal to 0 for x between a and b, then integral from a to b of f of x dx is going to be bigger than or equal to 0. So if function is always above the x-axis, the integral over the bound a to b and a is bigger than b, b is bigger than a, then that integral from a to b of f of x dx is going to be bigger than or equal to 0. So that's the first property. And so integral comparison property number 2, if f of x is bigger than or equal to g of x on the interval a and b, again b bigger than, and then, integral from a to b of f of x dx is bigger than or equal to integral from a to b of g of x dx. Again, b has to be bigger than a because it's an interval a and b. And so look at the two functions down there. F is standing above g all the times. Look at the area under f, that pink area. The pink area is bigger than the blue in the area under there is bigger than the blue area. So area, there's a pink and then the blue. If in integral property number 3, if f of x is between m and m on the interval a and b, then m times b minus a is less than or equal to integral from a to b of f of x dx is less than or equal to m times b minus a. Look at this function. It's the red curve, and then there's a blue line, y equal to capital M, and then the orange line, m and y equal to m. And if you look at this, the function stands between the two horizontal line over a and b. And therefore the area, let's see, this is the area underneath the blue line, and this is the area of the underneath the function, and this is the area underneath the orange line. And so you can see that the area under the function is between the area of it's the somewhere between the cyan and the orange, basically. Basically, the answer to this question is no. So, evaluating definite integrals as limits. The definite integral of f on the interval a, b is integral from a to b of f of x dx, and that's limit as n goes to infinity of the summation I equal to 1 to n of f of xi dx, where delta x is equal to b minus a over n, and xi is a plus I delta x, provided that this limit exists. Express the definite integral from a to b of 2x over 1 minus x to the third dx as a limit of Riemann sum. Okay, so how do we go about doing this? I click at question 6. Suppose that integral from 2 to 6 of f of x dx is less than or equal to integral from 2 to 6 of gx dx. Must f of x be always less than g of x for every number x in the interval 2 and 6? So think about this, see if you can find a counterexample or not. So let's look at this. Let's have basically a function g of x starting at 2 and then ending at 6, and let's say g of x is like this. Okay, and then let's say f of x is like this. Okay, and then if you look at this, you realize that the area that g of f of this was g of x, and this one is f of x. It's a constant function. So the area that g of x is above f of x is more than the area that g of x is below, but f of x is not always below g of x. So the area of this one is bigger than that one, but not f of x, g of x is not always bigger. So the answer to this one is also a no. Evaluating definite integral as limits. The definite integral of f on the interval a and b is the integral from a to b of f of x dx, and it's equal to limit as n goes to infinity of the sigma I equal to 1 to n f of xi delta x, where delta x is equal to b minus a over n, and xi is equal to a plus I delta x. Now, let's evaluate this, and let's convert this integral into that summation notation. So we start from integral. We start from integral from 1 to 5, 2x over 1 minus x to the third dx. So what is the function? Function is this one. So as I'm writing the other side of the story, let's replace the function first. Limit sigma I equal to 1 to n. I'm supposed to have f of xi. 2xi, 1 minus xi to power 3, and delta x. Okay, so what I don't want to have, I replaced the function. That was nice. Oh, I forgot the n to infinity. And then when I replace the function, now what I want, this xi is sort of unknown to me, so I want to replace it with something I know, and then this delta x is unknown to me. I wanted to replace it with something I know. Well, delta x is given here. It's b minus a. What is b and what is a? What is b? This one is a. This one is b. So delta x, let's write it on the side. Delta x is 5 minus 1 divided by n, which is 4 divided by n. What is xi? Xi is a, which was, we realized it was 1, plus 4 divided by n times I. So now I replace it, limit I equal to 1 to n of 2, 1 plus 4 over ni, divided by 1 minus 1 plus 4 over ni to power 3 times delta x, which is 4 over n. And so this, now that I'm looking at this, I see that inside the sigma, the only variables I see are n and I. N, for that n, it's okay. And I, because in general terms, should actually include I in them. Again, this one is I. There we go. And so that's how we find the limit sum. So now, again, with the same definition, what if the limit sum is given to me? How do I figure out what is what? In here, look at this function and let's compare. Now I have this side of the equation, and can you come up with xi in here? Let's first come up with xi. So I can see that these two are the same. So it looks like this is going to be limit sigma I equal to 1 to n goes to infinity of xi sine of xi, and then 3 over n. Wait, how does this compare? Look, delta x is supposed to multiply by I, and so it seems like this can work. So that would be a delta x. Now convert this. This is a better look because it looks like that now. Now you convert it back and you get integral from, and so let's see, when I chose xi, that should give me also a, so xi was chosen like that, right? And that is basically 2 plus delta x times I, or I times delta x. It seems like this should be a, and so the function is going to be x sine of x dx. Okay, a was easy to find. Now, let's see, how do I find b? Okay, so b is going to be basically as, so as you run I from 1 to n, the x runs from 2, as you run I from 1 to n, x runs from 2 to 2 plus 3. So the upper part is 5, basically. And we're done. Now let's evaluate some definite integrals. Let's start with integral from 1 to 3 of x squared minus 6 dx. And let's try to make it into a Riemann sum. Here, let's say delta x again is b minus a divided by n, that's 2 over n. Xi is going to be a plus I delta x, which is going to be the lower limit, which is 1, plus 2I over n. And then when you replace, you get, instead of xi to power 2, you get 1 plus 2I over n to power 2. I mean, you replace them with its value, minus 6 times 2n. And that's the limited sum that you get. You can take this a little further, expand the binomial 1 plus 2I over n to power 2 and clean it up. And then you can use the out of the 3 formulas that we use in 5.1, you can replace the values out of those formulas. And there were 3 formulas that we proved, and you get this answer at the end.